All right, so we said that a chemical reaction, there has to be a change in the molecular formula or the structure. However, the issues here is we can't actually see atoms/molecules and what they're doing, right? We can only see on the macroscopic world. You can see a glass of water, but you can't see the individual molecules and atoms that make that up. So how do we know whether a chemical reaction occurs? And the answer is without some kind of previous knowledge or without some kind of more advanced instrumentation, most of the time you don't know whether a reaction is a chemical reaction or not. There are some evidence for chemical reactions, but this is just evidence for it and not conclusive. So all of these pieces are evidence for chemical reactions, but it doesn't guarantee that it's a chemical reaction. One example is color changes, right? So when a compound changes color, that's a good chance that there's a chemical reaction occurring. Remember that color is the interaction between matter and light. So when we change the matter, then it's going to interact with the light differently and change colors. The formation of a gas. Many chemical reactions form gases. However, just because you have a gas doesn't mean that a chemical reaction is occurring. For example, when you boil water, that just goes from liquid to water to steam, gaseous water. That's not a chemical reaction. That's just a physical change. Heat absorption / emission. So an example of this would be like a chemical ice pack. You know, you have those little bags, then you crush them and they suddenly get cold. That's a chemical reaction occurring there. And then light emission. Sometimes our chemical reactions will emit light. That's another piece of evidence for a chemical reaction. But again, all of this is just evidence. It's not guaranteed. Right. And you could see any of these things and it could still not be a chemical reaction. You need to have some kind of background information or you need to study the system in greater depth.